Okay, all right. So wait, what's the derivative? What's the chain rule? F prime. Okay. Times g prime of x. Okay. So kind of the way you want to look at it is, notice you're getting the derivative first of the outside function, and notice how what happens to the inside of the it's the inside stays the same, right? So whatever the inside part is, you're going to leave it in there, and then you multiply it times the derivative of that inside. Okay? So, like for example, so let's say I want to find the derivative of, let's just say we have something like 3x squared plus 4x all to the 10th. Okay, so here, what's the inside and what's the outside? Yep. So 3x squared plus 4x is the inside. And then what's the outside function? It's x to the 10th, right? So the outside function is x to the 10th, and inside of that, you're plugging in 3x squared plus 4x. Does that make sense? Okay, so what does the chain rule say? It says get the derivative of the outside. So when you're doing this, you whatever you have inside, you pretend like it's just x. So like if I just had x to the 10th, what's the derivative of x to the 10th? 10x to the 9th, right? Okay. The difference is, so you do the 10, right? But instead of having x, you're going to leave the inside alone. So whatever is inside there, which in this case is, 3x squared plus 4x, you're going to just leave it in there. Right? So that's this g of x that you're just kind of leaving alone. Does that make sense? Okay, and then you're going to multiply that by the derivative of that inside. So whatever you have inside there, that inside function, you're going to multiply it by the derivative of that. So what's the derivative of 3x squared plus 4x? Okay. And that's it. Does that make sense? Okay, so that's, notice, one chain rule, right? So, but you can have multiple. Now, one that, it's not difficult, but I want to kind of isolate it because it confuses a lot of people. So what's the derivative of, say, 3 to the 2x minus square root of x, let's say? Something like that. So what's the inside and what's the outside? The inside is 2x minus root x, right? And what's the outside function? 3 to the x. Does that make sense? So the inside function is this right here, 2x minus root x. Minus root x. And then the outside function is 3 raised to the x, right? Okay, so what do I get the derivative of first? 3 to the x, right? Okay, so what's the derivative of 3 to the x? Three to the x times natural log of 3, right? Okay, so that's kind of the way you want to look at it, is it's 3 to the x, except that instead of x, you just leave in there what was already there. Does that make sense? Okay, and then I'm going to multiply it times ln of 3. So what was in there? It was 2x minus root x. And then what? Then I'm going to multiply by the derivative of the inside function, right? What's the derivative of 2x minus root x?
2 minus 1 over 2.
Yeah. So the derivative of root x is 1 over 2 root x, or 1/2 x to the minus 1/2. Okay, so does that make sense? So far, so good? All right. All right, so let's step it up a notch here. So I'm going to give you guys one to try. You ready? So not much harder, just a little bit. Let's see. How about the square root of x plus 2x minus 1 to the fourth. Okay, give it a go. Yeah. They're close. They're similar. Yeah, so if you look at, so what's the outside? It's the square root, right? Okay, so what's the derivative of the square root? It's 1 over 2 square root of, leave everything alone, right? Okay. All right, and then times the derivative of the inside right here, right? Okay, now, what's the derivative of the inside? Well, it's the derivative of x, which is 1, right? Plus the derivative of 2x minus 1 to the fourth, right? So 2x minus 1 raised to the fourth, that's a function. To get the derivative of 2x minus 1 to the fourth, you have to use the chain rule, right? Okay, but notice that you're using the chain rule on the function 2x minus 1 to the fourth. So if you get the derivative of this function right here, right? And you're going to put it right there, because that's where it goes, right? So what's the derivative of 2x minus 1 to the fourth? It's 4 times 2x minus 1 to the third, right? The power rule. Leave the inside alone, and then times the derivative of the inside. Notice that this chain rule is on the function 2x minus 1 to the fourth. It's not like so the mistake it's really common, this one, it's like you start just getting derivatives of insides and you just kind of start throwing them at the end of the function. It's like, okay, well, I know that I need to get the derivative of this, and so you just start throwing it outside without regard to where it actually should go. So yeah, you just have to be careful, right? So it's a simple mistake, right? It's just basically this, really, right? Like that. Because the 2 comes from getting the derivative of 2x minus 1 to the fourth. It's the little mini chain rule inside of the other one. Yes?
It means in the exam we run.
Yes. Because it will be wrong. This is correct. Okay. All right. I'm going to give you guys another one. See? But now that you know, knowing is half the battle. Oh, yes. Go ahead.
At this point,
What is it? Well, yeah, you should. Well, yeah. So this 2 and this 4, you can multiply it to be 8, right? Is that what you're talking about?
what's going to become the numerator?
This one? This 2 right here?
Yeah.
Nope. Because you have this 1 right here. So you have to be able to factor out a 2 from the whole thing.
Inside. Part of the outside, or is that?
Well, it's part of it's the inside of the first chain rule. But then inside, when you're getting the derivative of the inside, then you had another chain rule in there.
So then, part of it.
Exactly. Yep. That's exactly right. And then you close it off right here, like that. For the derivatives, yeah. So for just evaluating derivatives, I'm not going to ask you guys to simplify. Yeah. but you want to be careful because the next chapter is applications of derivatives, and there you're going to have to simplify to be able to use the derivative. So, but just for the purposes of making sure you know how to calculate derivatives, I'm not going to ask you to simplify.
What about
No, in general, it's better to simplify. Yeah, for sure. Because if you're going to find the derivative, you're probably going to use it for something. And so if you're going to use it for something, you're going to want to simplify it.
That's what I'm saying.
Yeah. Yeah, because like, one of the big things is optimization. So then you have the function, the derivative, and then you need to set it equal to 0 and solve an equation. So to do that, you have to simplify it, You have to. So, okay, I'm going to give you guys another one. You ready? Oh, wrong color. Okay, how about, let's do e to the Okay. All right. Give it a go. Okay. So here we have. So the outside function, I think we all agree, is e to the x. Yes. Okay. So what's the derivative of e to the x? E to the x, right? Okay. So the derivative of this is going to be e raised to the x. Now instead of x, what do you have? You have leave everything there, right? All that stuff. Yes? Okay. Then what are you going to do? You're going to multiply it by, well, I won't close it because we might need more space. But in here, what am I going to put? I'm going to put the derivative of, and I noticed some of you guys liked writing down what you're actually going to do in the next step, which is fine. So I'll write it down right here below. So I'm going to get the derivative of what I just wrote down here in the red, right? So all of the inside of the exponential function. So it's the derivative of square root of x minus 1 minus square root of x plus 3 all to the fourth, right? So like that's what I'm going to put in there. Yes? You with me? Okay, so to get the derivative of that, what rule do I have to use? That's another chain rule, right? Because you have another function inside of a function, right? So here, now, so if I look at it as, it's kind of like you're looking at it as a new problem. So at this point, what you want to do is no longer think about the e that you had earlier because you already dealt with the e. Now you just hone in on your new problem, which is right here in the green. So now you have basically x to the fourth, right? And you're just going to do the chain rule on that. So it's like you have a brand new problem. It's just getting the derivative of all that stuff raised to the fourth. So then how would you do that? You would do do the power rule, right? So it would be 4 times all that stuff to the third, right? So all that stuff is square root of x minus 1 minus square root of x plus 3, like that, right? Times the derivative of let's see here. Is it okay if I do right up here? Derivative of square root of x minus 1 minus square root of x plus 3, which is what I'm going to put right there. And then I can close off. So far, so good? Yeah? Does that make sense? Okay, so what is the derivative of square root of x minus 1 minus square root of x plus 3? And then minus 1 over 2 square root of x plus 3, right? So what do you guys think? Is that okay? Yes,
Does
Alex.
there have to be a parentheses around the operation that's 4 times square root of x minus 1 minus square root of x plus 3 to the third? Does that have to have a parenthesis, that whole portion?
You mean the black parentheses? The black set of parentheses?
Not over the total of it, but just the first part of it. where
This one right here? Or this big one?
That whole, not the whole one, but just the first part of it. So
This-
parentheses in front of the 4 and after the third power.
That one, yeah, that one definitely does because you're raising it to the third power. So if I take this off,
No, he's saying add them to the outsides of those.
To
So
the
add
left
the ones
of
you
the
took
4
off.
and then to
and
the
then add
right
another
the
set.
power of 3.
The multiplication sign is kind of the same thing.
Yeah.
so okay, you're saying leave those there,
Yes.
but take out these big ones?
No,
No,
add
let's
another
take
one.
out at.
Because doesn't it change it? Because you're the same. No, I guess not. No.
Saying if you wrote another set of parentheses, the first one being the left of the 4, the second one being the right of the power of 3.
Oh, adding a parentheses. Oh, like this.
Yeah.
Oh, I see.
The multiplication sign does the same thing.
And
Yes.
Is that the same thing?
Yes. So both of those are okay. Either one is fine. I tend to not add parentheses if they're not necessary. So actually, I put these right here, the big ones, because it's part of the chain rule. But in reality, you don't really need those either. You can take these off, and it's exactly the same thing, right? Because this is times.
No.
It's not the same. Sure it is. Because the order that you multiply, it doesn't matter, right? So if I leave that there like that, or if, right? So like if I write this down, okay. All right. True or false?
True.
Yeah, right? I mean, because how do you multiply three things? Do you multiply three things all at once? No, right? You multiply two, and then you get the result of that multiplied by the next thing, right? So whenever you do this right here, well, you have to either multiply A times B and then multiply that times C, or multiply B times C and then multiply that by A, right? So it doesn't really matter.
Yeah, you got the previous one, because then why did we do it the previous one?
Yeah.
So on that one,
Yeah, that's-
we have the parentheses around the.
Well, I changed. Well, yeah. So, but remember, so this is a modified. So originally, when I gave it to you guys, it was like that.
Right.
So,
Well, it's the same thing.
So what's the difference?
because
Is
there's
it?
a 1 right there.
It's not the same.
There's a
Look at it.
plus.
Look at it closely.
There's
You're
a plus
adding,
in there.
you're adding the
Oh,
one
I
with
get
the
it.
4
Yeah,
times
yeah,
2
yeah.
and then multiplying
Yeah,
it by
yeah,
2
yeah.
where
I
it's
see
the
what you mean.
opposite.
Yeah. So it's subtle. That's the thing is it's little things, but yeah, you just have to be careful.
Okay.
Good times. Good times. Good times. Fun times. So one thing that so you guys probably haven't taken a look at this yet, but if you go to, let me see, what section is the chain rule? I think 3.10 maybe.
It's 3.11.
So quotient rule, chain rule. So these are all, so 3.11 is the chain rule. So all these are video exercises. Notice how they go up in level of difficulty. So all these are, I have them on videos. So Whenever you get a chance, kind of go through, kind of just start going through them and see if you, you already know the chain rule, but just try them. You don't have to watch all the videos. Well, I thought I had the answers there, but just try to do them all, and then if you get stuck on one, watch the video and whatnot, and but yeah, work through them in order, and some of these are kind of simple, but then they get a little bit more crazy. Like this one, this is a good one. Root 1, then you got this craziness. Should we do one more? Or do you guys want to start implicit differentiation? What should we do? More chain rule or implicit differentiation? Yeah, I mean, I'm just looking at the clock, and I don't know if starting a new topic is exactly a good idea right now. Okay, so here, I have a question. Why is the derivative of... So you guys told me it's 1 over x, yes? So where does that come from? You know? Mm-mm.
U to the power of 1 over x is equal to 11x.
Isn't it when you put like 8 to the 0?
Well, you can do it using the definition, but it's much more difficult. With the chain rule, it's easy though. So check this out. Okay, so we have the following identity: e to the ln of x. What is this? So this is from algebra. You guys remember this? E to the ln of x is? Okay. A to the log base a of x is? X. Okay, good. All right. There we go. Okay, so what's e to the ln of x? X. Good. Okay, so you guys agree with that? Okay, so you learned it in algebra, but you forgot it. Okay, which is okay. Now, if I get the derivative of both sides here, what's the derivative of the right side? 1. The number 1, right? Now, what's the derivative of e raised to the ln of x? Well, what rule do you have to use for that? You have to use the chain rule, right? Because it's a function inside of another function, right? Okay, so what's the inside function? ln of x. What's the outside? E to the x, right? Okay, so if I apply the chain rule here, so it's exactly what you've been doing, right? So if I apply the chain rule, what would I end up with? I would have e to the ln of x, yep. No, because we're trying to show this, right? So we can't just, yeah, it would be pointless. Yeah, times the derivative of ln of x, which is what we're looking for, right? I mean, that's what we're trying to figure out. Well, what's e to the ln of x? That's x, right? So that's the identity, right? That's x. So x times the derivative of ln of x equals to 1. So what's the derivative of ln of x? 1 over x. Ta-da! See? Proofs can be fun, right? And see, now you know. And like G.I. Joe said. What did G.I. Joe say? I'm not that old. Come on. G.I. Joe said?
Now you know, and knowing's half the battle.
Yeah, knowing is half the battle. Wow. I am getting old. Really. Jeez. I always thought when I started teaching, I was, 22 2 or 3 or whatever. And, you know, I would show up to class. I'm basically the same age as my students almost. And like, oh, yeah, he's so cool, you know. Oh. And I always wondered how long it would take for me to not be the cool teacher, you know. And then one day I was in class, and then some students were talking about this guy, this rapper, singing about thrift stores. So I'm like, I have no idea what any of you guys are talking about. So that's when I knew I had jumped the shark. I was done. And now you guys don't even know who G.I. Joe is. You know, it's like, so that's it. It's done. I have 2 kids, so forget it. It's over. Over. Anyways, back to math. Okay, all right. You guys ready for another one? Okay, how about natural log of, let's see, sine of the square root of x plus, let's see, we could do another log here. Okay. Okay, there you go. That's it. That's all. Easy. Easy. Oh, wait. Oh, my. All right. You guys ready? Okay, so we start off with the derivative of the natural log. Yes? So that's 1 over all that stuff, right? So 1 over x, so that means 1 over everything. Just leave it how it is, right? All that stuff like that. Okay, times the derivative of all this stuff, right? Okay, so now we have the derivative of, so I'm going to do this. Okay, so in there I'm going to put the derivative of all that stuff, sine of blah, 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 blah. Yes? Okay, so what's the derivative of sine of x? Cosine x, right? Okay, so then it's just going to be cosine of all that stuff, right? So square root x plus 2x minus 1 to the 5th. Okay. So far so good? Okay. Times the derivative of that square root business, right? Notice right now when I'm thinking of my next derivative, the derivative of the square root, am I worried at all about the ln? No, right? So we got the derivative of it, and notice we forgot about it. We got the derivative of sine, we forget about it, and now we're focusing on the square root. Does that make sense? So you want to, throw out all that stuff as you're kind of going through. So, okay, so what's the derivative of the square root of x? It's 1 over 2 square root of all that stuff, right? X plus 2x minus 1 to the 5th. Okay? Times? Now the derivative of this right here, right? Okay. So it's going to be 1 plus what? Okay? Times 2. Is that right?
Well, does the 2 has to be parenthetically included almost with the 1 plus 5 times what?
Oh my gosh. What happened? Where did I go? Wrong page. Oh my gosh, where am I? It's getting worse. Okay. Oh my gosh. What am I doing? I just want to zoom in right here. Oh, well. Maybe I should practice or something. Okay. So is that right there in the orange?
Should there be another bracket before the 1 plus 5, and then a bracket on the end of the 2 also? You have to distribute the 2 to the previous equation. It was very similar.
Um,
The little dot is the same thing, right?
no.
You have to get
Yeah, so notice the way it is right now, this, the square root, 1 over 2 square root business, this right here, is multiplying the 1 only, and then that's it. And then you're adding all that other stuff, right? So here, notice we're supposed to multiply this, the whole function, times the derivative of the inside. So the derivative of that inside has to go in parentheses. Yes? Okay. Now is the 2 in the right spot? This last 2 right here. Should it go there or should it go outside of the big parentheses?
That should be multiplying by 1 plus the 5, but it should be still in its own.
That's right.
That is right. Yes. That is right. The 2, because remember the 2 is part of the chain rule of this guy right here, right? So it's part of the chain rule for that only. So you get the derivative of 2x minus 1 to the 5th. That's 5 times 2x minus 1 to the 4th. And you multiply that times 2. You don't just throw the 2 outside of the big parentheses just because you feel like it, right? It's the chain rule for that little mini function right there. Yes?
Professor England give us some formula.
Uh-huh.
He said if we have sine x to the power something, and we can I come and write it?
You can, sure.
He said if we have this, he said this would be equal to this, right?
So this,
It's sine n to the
Yeah, sine n to the x. Switch the first part.
What? This one will be
oh yeah, I think you're
in your first term, it has to be sine n to the x.
like this.
like this?
No, but
the x is
the x
right,
there.
but the n is on the other side.
And
Sine n.
No, like this. Look at this screen. Like that.
Boom.
Oh yeah.
Yes. This is, yeah. Yeah, definitely. I mean, so, so this is true, correct. So what would be the derivative of this then? What's the derivative of sine n to the x here? What is that? Oh my gosh. N times?
Cosine x.
Mm-mm.
No, n sine x to n minus 1.
Oh, yeah.
Notice what rule did I use first? It's the power rule, because what's the outside function? It's x to the n, right? So the n is some constant, right? Like 2, 3, 4. It's like having x squared, x to the third, x to the fourth. So you use the power rule first, because that's the outside function. And then what am I going to multiply that by? Any n's there? Any extra n's?
No, it's the inside function.
Mm-hmm. Right. Does that make sense?
Alright. Now we can go back to the previous example and then in here we can write the square root of as x plus 2x minus 1 to the 5 powers and then the whole with the 1/2 power.
No, because so this is this, right? This is not the same as so I know what you're thinking. You're thinking of this. So this is not the same. Because here, what's the outside function? Sine is the outside function in this case, right? So what would this be? This would be cosine of x to the n, right? Times
and x to the n minus
n x to the n minus 1, exactly. Okay. Okay. All right, guys.